In section 2.3, you will learn primitive data types in Java. There are two kinds of data types in Java. One is primitive data type and the other is reference data type. There are 8 primitive data types. They are byte, short, int, long, float, double, char, and boolean. In this section, you will learn more about primitive data types. In Java, arrays and objects are reference data types. You will learn arrays in chapter 8, and from chapter 3, you will learn about objects. There are 8 primitive data types in Java. Among them, 4 are integer types. They are byte, short, int, and long. That is, when storing an integer, you must declare the data type from one of these. And there are 2 data types for floating point numbers. They are float and double. These 6 are numeric primitive data types. When storing one character, we use char type. So, char is the type for one character. And as a special type, there is a boolean. Boolean data only can have true or false. So when you determine the statement true or false, at the time you will use boolean type. We will see each of these 8 data types in detail. Let's compare the 6 numeric data types. You can declare variables like this. If you want to declare byte type, then byte and variable name. Short, variable name. Int, variable name. Long, variable name. Likewise, if you want to declare floating point numbers, then float variable or double variable. The difference between the numeric primitive types is their size and the values they can store. When you need to create an integer variable, consider which type of a variable should be declared among byte, short, int, long. At this point, we need to know how much data each data type can hold. Let's compare the storage size of integer types. These 4 are integer types. So, byte is an 8-bit storage size, and short is 16-bit, and integer is 32-bit, and long has a 64-bit storage. So according to this storage size, we can see how many numbers can be stored in each data type. You will see that the byte type will have the smallest data space. It has only 8 bits. This means that the number of data that can be stored in byte space is small. In fact, the smallest number that can be stored in a space in byte space is -128, and the largest number to be stored in byte type is 127. This means that we cannot store value greater than 127. The short data type provides 16 bits. So the smallest value that can be stored in a short type is -32,768. And the largest number in short type is 32,767. So if you want to store an integer 40,000, then it is impossible to use a short data type. Likewise, integer provides 32 bits of space, and this is the smallest number to be stored in int type, and this is the largest number. And long provides 64 bits of storage. So long can have most biggest number and most smallest number. So when working with small integers, I think it is a good idea to use byte or short type. And when dealing with very large integer values, use long data type. In most cases, I would recommend using int. So int is the most popular type. When creating a variable to store a floating point number, we also need to decide whether to use between float and double. Because float provides 32 bits and double provides 64 bit space, double data types can store much larger and much smaller real numbers than float. So in most cases, I would recommend using double for floating point numbers. Let's talk about a byte data type. The byte data type can store integers from -128 to 127. So storing an integer outside this range will result in a compile error. Here, this is the byte data declaration. So byte, and this is the variable name, and this is the value for initialization. 100, 127, and -128. These are all okay for storing value to byte type. But 128 is not possible because this is not in this range. So a compile error will occur. So when you use byte data type, you must be careful when storing data. The data should be within this range. And short is the same. This is the range of short data type. So if we try to store the data that is not in this range, a compile error will occur. So for example, 30,000 is okay and -32,000 is okay because these two numbers are within in this range. But we cannot store 40,000 and we cannot store -35,000 because these two numbers are not in this range. So these two lines, a compile error will occur. Now let's talk about int data type. This is the range of int data type. This is big enough and small enough to do something. So this is the range. So I think you will probably use the int data type the most. And this is the declaration of int data type. I think you are familiar with this. There is one important thing here. Look at this code. In this code, there are 6 integer numbers: 100, 20, 30, 5, 100, 230. These are all integer numbers. Then, what types are these? Are these bytes, shorts, int, or long? When an integer appears in the code like this, the computer considers these numbers are int. So even if 5, this is small number. Even if this is small number, the computer thinks this is int type. This is very important when evaluating expressions with mixed data types. I will explain this in detail later. Long type is the biggest integer type in Java. Long type has a big number and very small number. So if you need to deal with very large or small integer numbers, use long type data. There is one thing to note when using long type integers. When you use long data in the code, you need to add uppercase letter L or lowercase letter l to the number. See, this is the long data declaration. So this is the long type, and this is the variable, and this is the number to be stored in variable num1. And here you see there is the uppercase letter L. Here is also uppercase letter L. Here is the lowercase letter l. So like this, if you want to use long data in the code, please add uppercase letter L or lowercase letter l to the number. So this is that this tells the computer that this is a wrong number, not an other integer number. So this is very important. There are two types of floating point numbers. They are float and double. To distinguish the two, float data is followed by an uppercase letter F or lowercase letter f. If you don't add a large F or small f, then compile error will occur. So when you declare float data type, at first you write data type float and variable name and a number. Here you should add large F or small f. Double is a data type that can store very large or very small floating point numbers. Declaration and initialization of double variables will be done like this. Java assumes that all floating point literals are of type double. I will explain about this. Let's look at this code. In this code, there are four floating numbers: 88.7, 55.7, 90.5, and 3.5. What types are these? These four numbers are double type. If there are floating point numbers in the code, the computer considers they are double data type. Then there is a error in this code. What is it? This line has an error. Can you notice that? Because weight is declared as a float, this number should have uppercase letter F or small lowercase letter f. So this line should be like this. Like this. Okay, so you must remember that if there are floating point numbers in the code, they are double. So you should be careful when you put the data into the float data type. A char variable stores a single character. Character literals are delimited by single quotes. So these are all examples of character literals. But this is a little bit strange. Do you remember this one? This is an escape sequence character because there are two characters, but escape sequence characters are regarded as one character. And here are examples of declarations of character value. Top grade has a capital letter A, and terminator has semicolon, and separator has space. Space is also one letter. A character set is an ordered list of characters, with which a character corresponding to a unique number. Unicode is a character set used worldwide these days. In Unicode, numbers are assigned to the alphabet like this. Capital A is 65, capital B is 66, capital C is 67, and so on. And likewise, small a is 97, small b is 98, small c is 99, and so on. I hope you remember that the Unicode for uppercase A is 65 and lowercase of a is 97. Sometimes this is needed for coding. Let's see an example of character. I created 4 char variables in this code. A char variable grade stores capital letter A, and terminator stores semicolon, space stores space, and mark stores question mark. And then each character is printed out using system.out.print line. There's nothing particularly difficult here. You can create and store a char variable like this. So the final result of this print out is like this. So since space does not have any character, There's nothing here. Boolean is the last primitive data type we need to study. A Boolean value represents a true or false condition. The reserved words true and false are the only valid values for a Boolean type. So we can declare a Boolean data type like this. This is the data type, and this is the variable, and this is the value to be stored in Boolean data type. A Boolean variable can also be used to represent any two states, such as a light bulb being on or off. So, if only two situations are possible, a Boolean data type should be considered. Here is an example of a Boolean type. The Boolean variable done has false, and checked has true. If I print out these two Boolean variables, true and false will be printed out. So done is false and checked is true will be printed out. And then I assign the value of checked into done. So the value of checked will be assigned to done. This means that these two both have true. So finally, if I print out these two, then both will print out true like this. Up to now, we have studied all 8 primitive data types in Java.